Early humans observed birds, sparking the dream of personal flight. This aspiration has been a long-held desire throughout human history. The freedom of soaring through the sky captured the imagination. This scene symbolizes humanity's enduring quest to conquer the skies. Leonardo da Vinci conceptualized flying machines in his workshop. He created sketches detailing innovative aircraft designs. These designs were based on observations of bird flight. Da Vinci's ideas were ahead of the technological capabilities of his time. His work represents early attempts to achieve human flight. In 1903, the Wright brothers achieved a historic milestone in Kill Devil Hills, NC. They successfully piloted the first sustained, powered, and controlled airplane flight. This event marked the beginning of the era of powered human flight. The Wright brothers' invention revolutionized transportation and warfare. Their achievement paved the way for modern aviation technology and air travel. The first flight stands as a testament to human ingenuity and perseverance. Airplane wings are designed to generate lift through airflow manipulation. Air travels faster over the curved upper surface of the wing. Simultaneously, air moves slower beneath the flatter, lower surface. This difference in speed creates a pressure differential. Higher pressure below and lower pressure above results in upward lift. Thrust is the force that propels the airplane forward. The engine generates thrust to overcome drag. The tail section is crucial for directional control. It also helps maintain balance during flight. Proper tail function ensures stable flight. Early airplanes were primarily constructed using wood and fabric. These materials were chosen for their lightweight and ease of manipulation. The use of wood and fabric resulted in aircraft that were relatively fragile. These early designs represent the initial stage of airplane development. They showcase the ingenuity of early aviation pioneers. These aircraft paved the way for modern aviation technology. Early aircraft relied on wood and fabric for construction. These materials limited aircraft strength and durability. Modern aircraft utilize aluminum alloys for enhanced strength. Steel provides critical structural support in key areas. Advanced alloys further improve performance and longevity. The fuselage is the main body section of an aircraft, housing the cockpit and passenger cabin. Construction involves assembling prefabricated sections to form the complete fuselage structure. This assembly requires precise alignment and secure fastening of structural components. The process integrates various systems, including electrical wiring and hydraulic lines. The scale of the fuselage highlights the complexity of modern aircraft engineering. Quality control checks ensure structural integrity and safety throughout the assembly. Airplane manufacturing uses a modular approach. Wings are constructed independently from the main body. This separate construction allows for specialized assembly. Completed wings are later attached to the fuselage. This modularity streamlines the overall production process. Jet engines are a critical component of modern aircraft. They provide the thrust necessary for flight. Engines are typically mounted on the wings or fuselage. This placement ensures balanced weight distribution. Precise installation is crucial for safety and performance. Jet engines represent a pinnacle of aerospace engineering. Electronics are installed, forming part of the airplane's complex electrical system. Control systems are added, enabling pilot operation of the aircraft. Fuel systems are integrated to supply the engines with necessary fuel. These systems create an intricate network of interconnected components. Proper integration ensures functionality and safety of the aircraft. Aircraft interiors are outfitted in a factory setting. Seats are installed to accommodate passengers. Cockpit instruments are mounted for pilot control. Safety equipment is added to ensure passenger security. Jet engines operate by drawing in air from the atmosphere. The incoming air is then compressed to increase its pressure and temperature. Compressed air is mixed with fuel in a combustion chamber. The fuel-air mixture is ignited, causing rapid expansion of gases. These hot expanding gases are expelled through a nozzle. The high-speed expulsion generates thrust, propelling the aircraft forward. Wind tunnels are used to test airplane designs. Engineers use wind tunnels to simulate flight conditions. Testing ensures optimal aerodynamic performance. Wind tunnels help identify potential design flaws. Data from tests improves aircraft safety and efficiency. Aircraft undergo extreme temperature testing to ensure operational safety. These tests simulate harsh environmental conditions planes may encounter. Testing validates the aircraft's ability to withstand temperature extremes. This ensures reliable performance in diverse climates and altitudes. Emergency simulations are conducted to test airplane safety features. These simulations replicate real-world critical incidents. The primary goal is to assess the effectiveness of safety systems. Crew response during these scenarios is also closely evaluated. This testing ensures preparedness for potential emergencies. Structural stress testing simulates real-world flight conditions on an aircraft. The airplane structure undergoes tests to ensure it can withstand flight stresses. Testing pushes the aircraft's structure to its design limits. This process verifies the structural integrity and safety of the aircraft. Data from testing informs design improvements and safety protocols. Airplanes must adhere to strict safety regulations before passenger transport. These regulations are designed to ensure a high level of operational safety. Certification confirms the aircraft meets required safety standards. This process is crucial for protecting passengers and crew during flights. New technologies enhance airplane fuel efficiency. Improved fuel efficiency reduces overall emissions. Visualizations show these technological advancements. These improvements contribute to more sustainable air travel. Advancements aim to minimize the environmental impact. Electric aircraft represent a shift towards sustainable air travel. These designs explore alternatives to traditional combustion engines. Electric propulsion reduces reliance on fossil fuels. Hybrid designs combine electric and fuel-based systems. These innovations aim to minimize aviation's environmental impact. Supersonic airplanes are being developed to revolutionize air travel. They promise significantly faster travel times compared to current aircraft. This speed enhancement could transform global connectivity. Supersonic travel may reduce long-haul flight durations substantially. New possibilities for international business and tourism could emerge. The development of supersonic aircraft represents a major advancement. Before the Wright brothers, many attempted to achieve human flight. These early attempts faced significant engineering challenges. Many designs focused on mimicking bird flight, often unsuccessfully. Lack of understanding of aerodynamics led to numerous failures. Power sources were often inadequate or too heavy for sustained flight. Control mechanisms were primitive, making stable flight difficult. Ailerons, elevators, and rudders are primary control surfaces on an airplane. Ailerons control the airplane's roll, affecting movement around the longitudinal axis. Elevators manage pitch, influencing the aircraft's movement about the lateral axis. The rudder controls yaw, directing the airplane's motion around the vertical axis. These surfaces work together to enable controlled flight and maneuverability. Aircraft undergo rigorous quality control inspections during manufacturing. Technicians meticulously examine each component for defects or deviations. This includes structural elements, engines, avionics, and safety systems. Inspections ensure compliance with stringent aviation safety standards. Quality control aims to identify and rectify any potential issues early. This process is vital for ensuring the airworthiness and safety of the aircraft. Modern airports are hubs of global connectivity, facilitating travel and commerce. Airplanes embody years of innovation, connecting distant locations. Aircraft engineering enables efficient and safe air travel. Takeoffs and landings represent the culmination of aviation technology. Air transport plays a crucial role in globalization and cultural exchange.